Imagine being born buried under 2 feet of suffocating sand. You are the size of a ping-pong ball, completely blind in the pitch black, and the collective weight of 100 of your siblings is pressing down on top of you. Suddenly, a primal switch flips in your brain. You have to dig. You claw upward through the crushing darkness for days, gasping for oxygen that isn't there, driven by an intense, unexplained urge. And then, you burst through the surface into the cool night air, only to realize that the moment you breathe, the entire world is actively trying to kill you. Crabs, raccoons, and birds are waiting in the shadows. But you can't see them, and you don't even know what they are. All you know is that somewhere out there, past the dunes and across a minefield of predators, is an ocean you have never seen, whispering a silent command to your cells. If you run the wrong way, you die. If you stop to rest, you die. This is the deadliest race on Earth, and it is only the first 5 minutes of your life. Every single year, millions of baby sea turtles begin this impossible journey. It is one of the most harrowing, miraculous survival stories in the natural world. But for decades, scientists were haunted by a profound, seemingly unsolvable mystery. How does a creature that has just cracked out of an egg, with a brain no larger than a pea, know exactly where the ocean is? How do they navigate thousands of miles across a featureless, trackless underwater desert to the exact place they need to go, and then, decades later, find their way back to the precise, microscopic stretch of beach where they were born to lay their own eggs? To understand this incredible feat of natural engineering, we have to start where it all begins, in the dark, suffocating depths of the nest. When a mother sea turtle drags her heavy body onto a beach, she digs a deep chamber in the sand, deposits her eggs, covers them up, and returns to the sea. She will never see her babies. She will never teach them how to swim, what to eat, or how to avoid danger. From the moment the eggs are laid, the countdown begins. For about 2 months, the embryos develop in the warmth of the sand. But they don't emerge one by one. If a single tiny turtle tried to dig its way out of a 2-foot deep hole alone, it would run out of energy and perish before ever reaching the surface. Instead, they cooperate. It is a phenomenon scientists call social facilitation. Inside the nest, the turtles begin to hatch almost simultaneously. As they wiggle and squirm, they spark a chain reaction among their siblings. Together, they create a living, breathing elevator. The turtles at the top scratch at the ceiling of the nest, dislodging sand that falls through the gaps between their bodies to the bottom of the pit. As the sand accumulates below them, the entire mass of hundreds of tiny turtles is lifted upward, inch by inch. This journey to the surface can take several days. But they don't just burst out into the open whenever they happen to arrive. Emerging during the hot tropical day is a death sentence. The blazing sun would dehydrate their fragile bodies within minutes, and daytime predators like vultures and iguanas would pick them off effortlessly. So, the hatchlings wait. They have a built-in thermostat. As they approach the top layer of sand, they can feel the temperature. If the sand is hot, they freeze, remaining perfectly still just beneath the surface. They wait until the sun sets and the upper layer of sand cools down. This drop in temperature is their green light. Suddenly, the sand erupts, and dozens of tiny black shapes spill out onto the beach under the cover of darkness. The moment their flippers touch the open air, a biological frenzy detonates inside them. This is called the frenzy period. Their bodies are flooded with an intense rush of adrenaline and stored energy, driving them to crawl as fast as their tiny muscles will allow. But now, they face their first major navigational challenge. They are on a flat beach, surrounded by darkness. Which way is the ocean? The answer lies in an incredibly simple yet sophisticated visual system. Baby sea turtles are genetically programmed to look for the brightest horizon. In a natural, undisturbed ecosystem, the landward direction is dark. Dunes, bushes, trees, and coastal vegetation create a dark, solid silhouette against the night sky. In contrast, the ocean side is open and expansive. Even on a moonless night, the stars and the night sky reflect off the wide, flat surface of the sea, making the oceanic horizon significantly brighter than the land behind them. The hatchlings don't look for the moon specifically, they scan the entire 360-degree horizon and move toward the area with the highest intensity of light. This visual cue is incredibly reliable, or at least, it was for millions of years. Today, this ancient programming faces a modern nightmare: artificial light pollution. Hotel lights, street lamps, flashlights, and beach bonfires easily overpower the subtle reflection of the ocean. Confused by these artificial suns, millions of hatchlings turn away from the sea and crawl inland. They wander onto coastal highways, get trapped in swimming pools, or succumb to exhaustion and predators. For a baby turtle, a single stray light bulb on a beach can mean the difference between life and death. But for those fortunate enough to find a dark beach, their eyes guide them straight to the surf. The moment the first wave crashes over them, everything changes. The transition from land to water is instantaneous and violent. They are tumbled, tossed, and dragged by the powerful undertow. Yet, the moment they are afloat, their visual navigation system shuts off, and a secondary, entirely different steering mechanism takes over. Once they are in the water, looking for a bright horizon doesn't work anymore. The waves are high, the water is turbulent, and they can no longer see the big picture. They need a new compass. Scientists discovered that the moment baby turtles enter the surf, they switch to an orientation mechanism based on wave direction. When a wave approaches the shore, it slows down in the shallow water, causing the wave crests to wheel around and run almost perfectly parallel to the beach. This means that no matter what direction the deep ocean currents are moving, the waves crashing on the shore are always moving directly toward the land. Therefore, to swim away from land and out into the safety of the deep ocean, all a baby turtle has to do is swim directly into the oncoming waves. To test this theory, researchers conducted fascinating experiments. They placed hatchlings in small harnesses inside circular water tanks. When waves were generated from a specific direction, the turtles consistently turned and swam directly into the face of the mechanical waves. Even more telling, when scientists reversed the direction of the waves, the turtles immediately turned around and swam the other way. This wave compass is an elegant, mechanical solution to an immediate problem. By swimming directly against the forces pushing them toward the shore, the hatchlings ensure they are moving out into deeper water, away from the deadly, predator-thick shallow zones near the beach. However, this wave navigation system has a major limitation: it only works in the shallow surf zone where waves are actively breaking and moving toward land. Once a turtle swims a few miles out into the open ocean, the waves become erratic, shaped by local winds and complex weather patterns rather than the shoreline. In the vast, open sea, waves can move in any direction. If the turtles kept relying on waves, they would find themselves swimming in circles, trapped in the coastal danger zone. So, how do they navigate when the waves fail them? How do they find their way across thousands of miles of trackless ocean, where there are no landmarks, no coastlines, and no waves to guide them? To solve this part of the puzzle, nature equipped the sea turtle with one of the most mind-blowing biological tools in existence: an internal magnetic compass. Deep within the cells of a sea turtle's brain, there are microscopic particles of a magnetic mineral called magnetite. These tiny crystals act like miniature compass needles, reacting to the invisible lines of the Earth's geomagnetic field. But the turtles don't just use this magnetic sense to tell north from south. Their system is infinitely more complex. They actually possess a biological GPS. The Earth is wrapped in a massive magnetic field generated by the movement of molten iron in its core. This field isn't uniform, it changes predictably across the globe. Two key features of this field change depending on where you are: the inclination angle and the intensity. The inclination angle, or the dip angle, is the angle at which the magnetic field lines intersect the surface of the Earth. At the equator, the magnetic lines run parallel to the ground, so the angle is 0 degrees. At the magnetic poles, the lines point straight down into the dirt, creating a 90-degree angle. Between the equator and the poles, the angle shifts smoothly and predictably. At the same time, the total strength, or intensity, of the magnetic field also varies from place to place. By measuring both the angle of the field lines and the strength of the magnetic force, a sea turtle can determine its exact latitude and longitude on the planet. It can essentially read an invisible, global map written in magnetism. What makes this even more astonishing is how and when this system activates. Remember that frenzy period? When the baby turtles are frantically crawling down the beach and swimming through the surf into the waves, their brains are doing something incredible. They are calibrating their magnetic compass. As they crawl and swim in a straight line guided by light and waves, their internal computer cross-references their physical direction with the local magnetic field of that specific beach. It imprints the exact magnetic signature of their birth site into their memory. This process is known as geomagnetic imprinting. It is a digital save point written into the turtle's biology, a home address they will remember for the rest of their lives. Once the compass is calibrated and the turtle reaches the deep ocean, the internal magnetic map takes full control. This map is absolutely vital for their survival because of where they need to go. Take the loggerhead sea turtles that hatch on the beaches of Florida, for example. Once they clear the shore, they must find their way into the Gulf Stream, a powerful, warm ocean current that sweeps up the eastern coast of North America and circles across the Atlantic Ocean toward Europe, forming a massive, rotating current system known as the North Atlantic Gyre. This gyre is a safe haven for young turtles. Filled with massive mats of floating sargassum seaweed, it provides them with food, camouflage from predators, and warm water that accelerates their growth. The turtles will spend several years drifting in this giant oceanic highway. But the gyre is surrounded by deadly traps. If a young turtle drifts too far north, it will be swept into the freezing waters of the North Atlantic, where its body will shut down from hypothermia, leading to a quick death. If it drifts too far south, it can be pushed into currents that drag it to places where food is scarce and survival is unlikely. The turtles must stay within the safe boundaries of the gyre. How do they manage to stay inside a moving circle of water in the middle of a vast ocean? They read the magnetic map. In groundbreaking studies led by biologists, researchers built a specialized apparatus consisting of giant electrical coils that could replicate the exact magnetic fields found in different parts of the Atlantic Ocean. They placed young loggerhead turtles in a test tank surrounded by these coils and changed the magnetic field to match specific geographic locations along the edge of the North Atlantic Gyre. The results were staggering. When the coils simulated the magnetic field of the northern boundary of the gyre, near Portugal, where the water turns dangerously cold, the turtles immediately turned and swam south-southwest. Their internal programming told them they were entering a danger zone, and they adjusted their course to stay inside the warm current. When the coils were shifted to simulate the magnetic field of the southern boundary, near the Caribbean, the turtles instantly turned and swam north-northwest, avoiding being swept away from the gyre. These tiny creatures, who had never been out in the ocean before, carried a complete navigational chart of the entire Atlantic Ocean inside their DNA. They didn't learn this map through trial and error. They were born with it. Every milestone, every dangerous turn, and every safe harbor was pre-programmed into their genetic code over millions of years of evolution. For nearly a decade, these young turtles live a nomadic lifestyle, drifting with the currents, growing from the size of a teacup to the size of a dinner plate, and eventually into massive adults weighing hundreds of pounds. This period of their lives is often called the lost years because they disappear into the vastness of the open ocean, far away from human sight. But as they reach maturity, a profound change occurs. The nomadic drive fades, replaced by an overwhelming urge to reproduce. To do this, they must return to the shallow, coastal waters where they can find mates and abundant food. And when the females are ready to lay their own eggs, they don't just find any random beach. They embark on a journey that defies belief. They travel thousands of miles across open oceans, defying crosscurrents, storms, and human obstacles, to return to the exact same coastline, the exact same beach, and sometimes the exact same dune where they themselves cracked out of an egg 20 or 30 years prior. This brings us back to the magic of geomagnetic imprinting. The adult turtle recalls the precise magnetic signature it recorded during that frantic, adrenaline-fueled crawl down the beach as a tiny hatchling. Navigating back to that specific spot is like trying to find a needle in a haystack if the haystack was constantly moving. Because the Earth's magnetic field isn't completely static, it shifts slightly over decades. The magnetic address of a beach can move a tiny bit over time. Amazingly, scientists have found that the nesting patterns of sea turtles shift right along with these magnetic changes. If the magnetic lines move slightly down the coast, the turtles follow them, proving beyond a doubt that they are tracking these invisible forces with pinpoint accuracy. As the adult female nears the coast, her magnetic compass gets her to the right neighborhood. But to find the exact driveway, she begins to layer other senses on top of her magnetic map. Scientists believe that as turtles approach their home shores, they utilize olfactory navigation, their sense of smell. Every beach has a unique chemical signature. The specific combination of minerals in the sand, the types of local vegetation, the runoff from nearby rivers, and the unique microscopic life in the water create a distinct scent profile for that particular stretch of coast. During her first swim out to sea as a baby, the turtle didn't just memorize the magnetic field, she also tasted and smelled the water of her home beach. Decades later, as she approaches the coastline guided by her magnetic GPS, she smells the water. When she detects that familiar, chemical recipe from her childhood, she knows she has finally arrived. She rides the surf inward, pulling her massive, heavy body out of the water and onto the sand. It is a grueling, exhausting effort for a creature designed entirely for life in the sea. Gravity presses down heavily on her organs, and her flippers, so graceful in the water, must clumsily drag her bulk up the beach. She finds a spot above the high tide line, digs a nest chamber, and lays a new generation of eggs. As she covers them with sand and slowly crawls back into the ocean, the cycle resets. In 2 months, a new batch of tiny, vulnerable hatchlings will wake up in the dark, and the great, impossible race will begin all over again. The journey of a sea turtle is a masterful symphony of biological engineering. It combines the physics of light, the mechanics of ocean waves, the global forces of geomagnetism, and the chemistry of smell into a flawless, multi-layered navigation system. It is a survival strategy honed over more than 100 million years, allowing these ancient creatures to outlive the dinosaurs and witness the rise of humanity. Yet today, this ancient miracle is under threat. The navigation systems that served them perfectly for eons are being disrupted by human activity. Bright coastal developments blind their eyes, plastic pollution mimics the scent of their food, climate change alters the temperatures of their nests, and artificial structures block their paths. Understanding how these creatures find their way home isn't just a fascinating scientific endeavor, it is a critical tool for their survival. By knowing how they see, feel, and navigate the world, we can take steps to protect them by dimming beach lights during hatching seasons, preserving their nesting sanctuaries, and keeping the oceans clean. The baby sea turtle crawling frantically toward the horizon reminds us of the incredible resilience of life. Guided by the stars, steered by the waves, and pulled by the very magnetic core of the planet, they carry the map of the world within their souls, proving that no matter how vast the ocean, and no matter how long the journey, there is always a way back home.